What's up, everyone? So in the last couple of videos, we're working on high school algebras. So today I decided to take a short break from it and talk about something in calculus. So in this video, we're going to talk about something called the King's property in calculus. Probably most of you might have never heard of the name of it, but definitely know what it does. So where does this name come from? I have no idea, and I also know that most most people would not even use such name, but definitely there are some countries using this name, such as in Japan. They would definitely call it the King's property. What is the King's property? Well, before we talk about it, let's look at the fundamental theorem of calculus, part 2, which says let f of x with capital lies f be a differentiable function on an interval from a to b. In other words, this function capital F of x has a derivative in the interval from a to b, and later on I'll just call it lowercase f of x. Some people would just simply call it f prime of x just for clarification. But anyway, if we have this condition here, then for the integral from a to b of the first derivative, it will be equal to the difference of the two endpoints, capital F of A minus capital F of B minus capital F of A. Good. So now we have the definition of an integral, or at the same time, definition of derivative as well. So let's take a look at what the King's property said. Here we go. The King's property says that if we have an integral that looks exactly the same as above, from a to b of the derivative function, well, we know that the ending result has to be f of b minus f of a, right? Capitalize f. But we can also convert this integral into the following expression. We still have the integral from a to b, but we are still taking the same first derivative at a lowercase f, but instead of having x here, we're going to put a plus b minus x. So instead of taking the input x, the input now becomes the sum of the two endpoints minus x. So we can see see it. The function is kind of going backwardly when we are looking through a graph. So yeah, this is the King's property. But why is it true? And how does it help us? We're going to move on to the next board and take a look at the quick proof of it. Then we're going to look at a few examples and see how we can apply this property to some of the problems. Okay, in the last board we already talked about what is the King's property, and how it looks symbolically. So now we're going to talk about why it works, or how can we prove that. So here is the actual proof. First, on the left hand side, I'm going to use a dummy variable t instead of x so that we won't get confused in between. So I'm going to replace the x by t here. I'm going to use a different color to show that it's just a dummy variable. Then we're going to start. Nope, it's drying out. we're going to let t be what we have inside. Since we want to replace the input into some other new expressions. So we have t equals a plus b minus x. Then let's check. When t equals a, we see that x equals b. Well, we can just substitute in and check that if this is a, then we need a b here to cancel out. At the same time, when t equals b, x has to be equal to a. Again, just substitute in, we just check it quickly. And also, since we have dt here and then we want to make it into dx, of course we need to take the derivative of this expression. And we get dt is equal to, if we take the derivative on the right hand side with respect to dx, we get a as a constant, so it turns into 0. B is a constant, it becomes a 0. And then negative x becomes negative 1 times dx, or just negative dx. Good. So we already get everything that we need for the setup so that we can do the substitution now. Let's get into the actual proof. Then the left hand side, which is the integral from a to b of f of t dt, is now equal to, we're going to do the substitution. Replace the t by the expression a plus b minus x times dt here, which is now becoming negative dx. And then for the lower bound a, we said that it becomes b. For upper bound, it becomes a here. And finally, since we have a negative, we can pull it out and use the third part of the fundamental theorem that says we can just flip the upper bound and lower bound to get this. The integral from a to b, again, now the a, which is originally the upper bound, becomes the lower bound, and then the b, which is the original lower bound, and it turns into the upper bound now of the function f of a plus b minus x, and then dx, which is up here. Good. Now we have already proved that's why this property works. If we consider this problem here, let's say we want to take the integral from 0 to pi of, well, sine of x is definitely easy because we know the derivative, we know the integral of it. So let's make it challenging so that we now need to use this property here. I'm going to put a square. Okay. So how do we find out this integral, or the value of this integral? Well, of course, one way to do it is use the trig sub and try to no, not trig sub. Yeah, some of the trig properties to make it into degree 1. Then we'll be able to use the antiderivative of the trig functions to get our result. But we can also use the property that we have learned to get the answer quickly. So let's call this integral I here. Then using the King's property, we say that I is also equal to, again, we see that the interval is not changing. The only thing that's changing is the function inside. Well, the expression of the function inside. Again, now we can just use x here. And what is our original function of x? Well, we say that this is our original function. So we have f of x is equal to sine square of x, which is known as the square of sine of x. Okay, so now how do we turn it into this expression? We get f of a plus b minus x equals, well, let's see. We still have the square outside. Now, instead of sine of x, we need to replace the x by everything inside in the input, like this. Okay, but what's a and what's b? A is our lower bound 0. B is upper bound, which is pi over 2 here. So we get that by substituting in, we have sine of pi over 2 minus x quantities. Okay, the square of this quantity. Now, keep in mind, we're not done yet. Why? Because one of the trig properties said that sine of this is just equal to cosine of x. Meaning we have the square of cosine of x here, or cosine square of x. So by the King's property, we can replace the sine square of x into cosine square of x dx. Good. And up to here, you might say, well, we didn't really make it any easier. We still have a square of trig function, right? But this is why we use the King's property. Now we say that these two are actually the same integral, which is namely I. If we add these two integrals together, of course, the left-hand side turns into 2i because we have I times I plus I. Now on the right-hand side, we have this plus this. And seeing that the upper bound and lower bound are the same, we can now use an other property in calculus that says we can just simply add the two functions together inside before we take the integral, as long as both functions are actually defined in the union of the two intervals. Okay, and since we know that they're in the same interval, their sum must also be defined or well defined in the interval. So we are going to add the two functions together. And what do we get? Remember, we have in trigonometry class, one of the first few properties that we have learned is the Pythagorean identity, which says sine squared plus cosine squared equals 1. So we can now simplify the sum of the function into just 1 times dx, which is the integral from 0 to pi over 2 dx, which means by taking the integral, we will just have pi over 2 minus 0, which is pi over 2. So now, to find out what I is, we just need to divide by 2 to get that I equals pi over 4. Okay, that's it. I hope you all enjoyed this video. And if you have any thoughts or questions that want to ask me about this property, don't forget to leave your comment below. And of course, if you have any other suggestions as well, you can also do that. And again, please don't forget to like and subscribe my channel to find out more of my videos, and also turn on the notification so that you won't miss any of my new videos. I'll see you guys next time.